with set theory. Specifically, we'll be proving set laws. And then at the end, now we're going to do questions. We're going to do the questions that we sent for the quiz the previous time. Okay. So now we had already mentioned the laws of sets, the associative law, the distributive law, the law of commutativity, and the Morgan's law. Those are the ones we need to prove. Let's start with the commutative law. Now, commutative law is so direct anyway. Okay, commutative law. Now, we know that commutative law is A intersection B, the same as B intersection A. Now, or we can also use union. A union B is the same as B union A. This one is too direct. There is nothing much to talk about here when verifying. This is just a reversal. Okay. So what I'm going to go to, which we need to verify, let's start with the law of associativity or the associative law. Now we had already mentioned last time that for the associative law, it has got three components. Let's say we are talking about A intersection, we have got B intersection C, and this is going to be the same as me starting with A intersection B. And then the answer that I get, I intersect with C. So we said the associative law applies when we are using the same sign. Let's say if there was a union here and they should also be here. Okay, not where you have got union and intersection. It will not always be true. So that is the associative law. Now, how do we prove the associative law? Proving these laws, you are going to get the left hand side and the right hand side of the equation that you've been given. You need to prove. Now, this is based on this principle. It is based on the principle of subsets. Look at this. If you have got this big set here and a small set inside, let's say a small set inside is A, the big set is B. So I'm going to say that A is a subset of B. Okay, like that. Now, let's say you've also been told, okay, let's say we also have B, it is inside A. This would mean that B is a subset of A. Okay, A is a subset of B and then B is a subset of. Now, imagine if these two sets, like, you don't know the diagram. You've been told that A is a subset of B and B is also a subset of A. There is a meaning for that. If A is a subset of B and B is also a subset of A, you know what that means? It means that these two sets are equal. This means that B is equal to A. In other words, it's the same thing. Imagine the set B can go into the set A. The set A can also go into the set B. The only way that can happen is that the two sets are going to be equal. Okay? That is very important to understand. And that is a principle that we use when we are proving these laws. So what you are going to do is you are going to get the left hand side. This is going to be the left hand side. This is going to be the right hand side. You want to prove that one side is a subset of the other, and then the other side is also the subset of another one. So it is important that we understand that. So how do we go about this one? So the first, what we are going to do is we are going to let any letter be equal to one side that we've been given. So let's say we say let x. Now instead of x being equal to, we are going to say let x be a member of. Okay, let x be a member of the set that you've been given. So the set on the left hand side, that is A intersection B intersection C. So you can choose any letter that you want, but best to use X, right? So we want X to be a member of the set on the left hand side. Now the meaning of this is, if X is a member of, now there are some terms that you need to know the meaning of the word and in sets. When you are dealing with sets, the word and means intersection. The word or means union. So this is what you want to have in your mind. So as we are proving this, where we have got the word and, we are going to put, where there is intersection, we are going to put and, right? So we're going to say X is a member of, where there is that intersection there, what we are going to put is and. So we're going to say A and B intersection C. Hope this is not confusing. Please, if it is confusing at any point, be able to mention. And then since it is like this also means that X is a member of A, and I'm also going to put where there is a B, intersection here. I'll again put the word and. So I'll also say X, okay, not X again, but I'm going to put B and C. What have I done? I've just put where there is intersection here, the word and. Please, if it's confusing at any point, be able to state, right? Now, since I want to show that this side, which is the left hand side, is the same as the right hand side. But look at what we started with. What we started with, the last two were together. So now I'm going to pair the first two. I'm going to remove the word and from the first two. So I'll say now X is a member of, I'll say A, instead of having this word and, I've changed. I'll put intersection there. B, okay? And then I'll now just write this other and at the end, and then I'll write C. This also means that X is a member. I'll put now the A intersection B in brackets. Now where there is this word and, I'll put again intersection C. So you've seen what we've shown. So when you do this, what we have done here just means that what we had started with, what did we start with? A intersection B intersection C. So you can see that what we started with is giving us what is on the other side. This means that what we started with is actually able to go, or is a subset of what is on the other side. What is on the other side is what we have determined: A intersection B intersection C. So we have shown that the left hand side is a subset of the right hand side. Do we have any question here? At least if there's no question, you can tell me that this is okay. Are we good? Okay. Now, just like we have done, we are going to say conversely. This just means the same way. Now we're going to say that we are going to show that the right hand side is a subset of the left hand side. So we're going to say conversely, let X be a member of. Now we are taking the right hand side. The right hand side is A intersection B intersection C. Okay. So this will mean that X is a member of A intersection B. Where there is this intersection, I'll put the word and. You can actually even put this in brackets and C. And then this will mean that X is a member of, on this other intersection, I'll put again and. So it will be A and B. Remember there's another and C. Now from what we have here, this will mean, remember for the question itself, we had the first two. So I'll pair up now the next two. So I'll say X is a member of, I'll write A. I'll still write this word and here, but then for the last two where there is the word and, I'm going to put intersection C. I can even put this in brackets. This will mean that X is a member of A. Now where there's the word and, I'll now put intersection, and then B intersection C. So what we have just done, what we started with, A intersection B intersection C, this means that it is a subset of what we have found, which is A intersection B intersection C. But remember we said that if the left hand side is a subset of the right hand side, and the right hand side is also a subset of the left hand side, that means that the left hand side and the right hand side are equal. So that is how you need to finish your statement. Since left hand side is a subset of the right hand side and right hand side is a subset of the left hand side, then left hand side is equal to right hand side. So that is how we're going to be able to show. That is how you show the law of associativity. So we have proven, or we have verified, the associative law. Let's verify the distributive law. Yes, Leah. Okay. Now these tutorials are always available. So I hope you guys don't concentrate just on writing, because these tutorials are always available. So there is always that time that you can still copy. That is the goodness. Because if you pay too much attention to copying than to understanding, to give you a problem. Okay. So I advise you, just be taking note of some important things that you think you can, but the tutorial will be available. So mostly it's the best that you get to more listen. Okay. Okay, let's prove the distributive law. So A intersection, let's say we have got B union C. Remember for distributive, we said that you just get A intersect, you distribute to the B. So that becomes A intersect B, and then the sign which is inside, which is the union, and then get A intersect, you distribute with C, so that will be A intersect C. So this is what we want to prove. Just like the previous one, it is same proving this one. So let X be a member of, we'll get the left hand side. And the left hand side here is A intersection B union C. Now, we know that the meaning of the word, where there is intersection, so we can say X is a member of A. Where there is intersection, what am I going to put? What word am I going to put there? And. Very good. So I'll say X is a member of A and B union C. This will also mean that X is a member of A and, what of where there's union? What word am I going to put? What word am I going to put there? Yes, Leah? O. Thank you. O C. Now, what I want you to get here is this. X is a member of A and B or C. Now, the meaning of this is, imagine I tell you go and buy a pen and a book. Sorry, go and let me start with a book. I want you to understand this so that you'll not forget. Go and buy a book and a pen or pencil. What do I mean? Which one should I always come with amongst these three? Go and buy a book and a pen or pencil. So which one is a must buy? Anyone? Thank you very much. Okay. A book. You need always to buy a book, but then there is a choice for me to buy either a pen or a pencil, meaning that I can either go with a book and a pen, or I can go with a book and a pencil. So this is how we are going to change here. So it becomes X. Remember, it is X the member of A and B or C. So this means that X can be a member of A and B, or X can be a member of A and C. Very important. So I can go with A and B, or I can go with A and C. This means that X is a member of, I'll now put A where there is, and I'll put intersection B, or X is a member of A where there is, and I'll put intersection C. This means that X is now going to be a member of A intersect B, where there is O, I'll put now union, and then where they, I'll write the other side A intersect C. So what we have just shown, remember this is the left hand side, this is the right hand side. So what we have just shown is we started with the left hand side. This means that the left hand side is going to be a subset of the right hand side. Okay, is there a question here? Are we good? Should I proceed? Okay. So please, if there's a question, you can just open your mic and then be able to speak. Conversely, or in the same way, we are going to let X be a member of the other side. A intersection B union A intersection C. This will mean that X is a member of A intersection B, but where there is a union, I'm going to put O. X is a member of A intersection C. This also means that X is a member of A, where there is intersection, I put, and B, or X is a member of A, where there is intersection, I put, and C. But if X is a member of A and B, or X is a member of A and C, this means that X is a member of A and X. Okay, let me not write that X again. This means that X is a member of A and B or C. In other words, B and C, there is a choice. We can get any one of them. And then from this, we know that this means X is a member of A, alright, and I could have said X is a member of B or C there if I wanted, but anyway, it's still okay like that. Now, where there is B or C, where between them, what am I going to put? I'm going to put union. and this will mean that X is going to be a member of A. Now where there's intersection, I put now, I mean where there's, and I put intersection B union C. So you've seen we have gotten to the left hand side. So this means that the right hand side which we started with is a subset of the left hand side. And we said if the left hand side is a subset of the right hand side and the right hand side is a subset of the left hand side, that means that the left hand side and the right hand side are equal. So if they brought that, it is important for you to write the last statement like that. Okay. Now let's prove De Morgan's law, or we verify De Morgan's law. Is that a question? Please, you can go on. There's a hand. You can open your mic and speak. Okay, it seems there's nothing. So let's prove De Morgan's law. Let's say we have got A. Which one should I prove? It's all the same anyways. A union B complement, and we know that this is the same as if we distribute the complement, the sign changes on the middle. We are going to start with the left hand side. Let X be a member of A union B complement, alright, like that. The meaning of this is going to be that now look at this one. This one is the most trick out of them all because there is a complement. So X is a member of A union B complement. This means that X is not a member of A union B. Because it is a member of A union B complement, it means that it's not a member of A union B. This is what you want to understand for this one. Have we gotten this? Please ask if there is a question. Is this clear? Okay, I hope people are understanding. So if an element is part of a set, it means that it will not be outside that set. And if an element is outside that set, it means that it will not be in that set. Hope you get that. So X is a member of who? The complement, meaning that it can't be inside the set itself. That's the meaning. Since X is a member of A union B complement, it means that X is not a member of A union B. Is that okay now? It's not? Okay. Now, this is the only thing that is different out of these others we've been talking about. Because we are saying not a member, the word or will not represent union. Okay? Because we are saying it's not a member. So in this case, X is not going to be a member of A, and X is not going to be a member of B. You've seen the difference? X is not a, the word union is being represented by and because it's not a member. Look at this. If you have got, this is your set A, this is your set B. A union B is everything inside here and inside here. Okay. So if we say that X is not a member of A, meaning that everything outside A is what we are talking about. Okay. And then X is not a member of B. Let's say, okay, look at this. X, this is A, this is B. X is not a member of A means everything outside here, okay? And then X is not a member of C means everything outside, sorry, outside B. Now, how best do I represent this so that you can see? You need to understand why we are not using the word or there. Instead, we are using the word and. Okay, so let me find X is not a member of A means it's outside A. So in other words, we're just finding A complement. So A complement is going to be the entire of this set. Everything outside the set A. And then X is not a member of B means we are talking about everything outside the set B. So that is what we are going to be able to shade. Everything outside the set B. So I have shaded, what I've shaded there is everything outside the set B. Now remember A union B complement, if you want to shade it like just itself, if this is A, this is B, A union B complement is supposed to be like everything this side. Okay, everything this side. So and means where sets are intersecting. Look at this, look at the green lines which I've drawn and the red lines. Where they are intersecting is this region. If I had used the word or here, it would have meant union. Union means I would have also included this part. I would have also included this part. And that is not the same as this set. You see that? That is why we are using the word and. Okay? It's very important to understand that. Okay, so from here, this means that X is not a member of A where there is and. Now I'll put intersection. And then it's not also a member of B. What does this mean? Okay, before I even do this, before I do this, this will mean that since X is not a member of A, what does that mean? It means that X is a member of A complement. And if X is not a member of B, that means that X is a member of B complement. And then this will mean that X is a member of A complement. But and now we can put the word, what word are we going, what our sign are we going to put? Intersection. Okay, and then B complement. So we've seen, we have just shown that the left hand side is a subset of the right hand side. And then conversely, you are going to use the right hand side. So let X be a member of A complement intersection B complement. And how, what is that going to mean? This will mean that X, okay, is going to be a member, is not going to be a member first of all. Okay, since X is a member of A complement and X is a member of B complement, mean that X is not a member of A, and also X is not a member of B. Why? Because these two guys were members of the complement. All right, so that is the meaning here. Hope people are following. Are we moving together? Are we moving together? Okay. Now, this will mean that X is a member of A. Now remember, this word intersection is supposed to mean and, but because this is not a member, what are we going to use? We'll use O, not a member of B. This means that x is going to be, look at this, is going to be, now we are going to put this, x is going to be a member of A. The word O now changes. We'll now put union B. And the reason as why I'm doing that, look, I've changed from, it was not a member, but now it has become a member. Okay, now let me not join these two steps so that someone might not be confused. I can start with, which one do I even start with? Okay, I can start with this one. Where there was the word or, I've changed it into union. Now, not a member changes into a member. When it becomes a member, since it wasn't a member of A union B, it means that it is a member of what is outside A union B. And what we have done here is that the right hand side is a subset of the left hand side. Remember, this is the left hand side here, this one, which is this one. Since the right hand side is a subset of the left hand side and the left hand side is a subset of the right hand side, that means that the left hand side and the right hand side are actually equal. Okay, so that is how we are going to show these laws. All right, so that is it on showing these laws. Now let's go to our questions and answer them. So the first question which was given is here: given that the sets A from -3 to 2, B from 0 to 7, and C from -5 to 1, and the inverse set is from -10 to 10, find each of the following sets and represent them on the number line. So there are two questions here. You are finding and also representing on a number line. Now, if you look, for me, how I answer these questions, when you have got A intersection B complement, I always start with something that has got a complement. It is much easier like that. First, I'll get my number line. I'll first ask myself if they've given me the inverse set. If they've given me, I'll just get the values of the inverse set. The limits consists from -10 up to +10. Are we including 10 and -10? Anyone? Are we including 10 and -10? We are not including. So are we going to shade or we are going to leave the circles open? Are we going to shade or we'll leave the circles open? Okay. So every time you see these brackets, so I sent the class that we did the first one. Please watch if you didn't watch. I've seen there are people who didn't watch. That's why that question has come to say why are we not including. So please watch the class that we did last time. So when you see this kind of brackets, it means that we are not including the terms. If you see this kind of brackets, means that we are including the terms. So when we are not including the terms, you leave these regions open. Okay, I'll just write that. Now I'm going to go because I want to first find B complement. I'll go to where the set B is. Now you can see that B is starting from 0 up to 7. So 0 is going to be somewhere here and 7 is going to be somewhere here. Remember, what I want to find is B complement. Okay, what is outside B? Am I including 0 in B? Okay, I am including 0 in B. So in B complement, am I going to include 0 or not? No, I won't include it. So I'm going to put an open circle here. And then 7, you can see it is also being included in B. So in B complement, 7 will not be included. So I also put an open circle. Just draw a line going in this direction. Draw a line in this direction. So the set I've written here is B complement. Because B itself was supposed to start from here up to here. This was supposed to be B. That is how easily you find, other than you drawing B and then you come and draw its complement. Yes. Mhm. Please, you can say again. We are asking a question or something. Okay, I can't get what anyone is saying. Okay. So what I'm saying is this. Before you answer any question, make sure that you understand your universal set. If they're given the universal set or not. In this case, the universal set has been given. It's from negative 10 to 10. Kindly switch off your mic. Okay. From negative 10 to 10. Now negative 10 is not being included. I'm going to put an open circle. 10 is also not being included. I also put an open circle. I'm just marking my universal set. I can't go beyond 10. I can't go beyond negative 10. I'm going to go to my set B. Remember, what I'm interested in is finding B complement. So set B is starting from 0 to 7. We are including 0. Since I'm including 0 in the set B, it means that I'll not include 0 in B complement. So I'm going to put an open circle at 0. And we're also going all the way up to 7. Since 7 is being included in the set B, it means it will not be included in the set B complement. So I also put an open circle because what I want to find is B complement. And I'll simply join this side and this side. So this is the set B complement. Now I'm going to get my set A. The set A starting from negative 3. Negative 3 will be somewhere here up to 2, somewhere there. Now, is negative 3 being included in the set A or not? Not included, so put an open circle. How about 2? 2 is included, so we are going to shade. Okay, we'll shade there. That is our set A. Now remember, we want to find where these two sets are intersecting. So where is the set A and the set B complement meeting? You can see it is between these 2 points. Yes, good. Okay. So already if I do this, I've answered one part of the question. And the show represent on the number line, I've answered, I've shaded there. Now what is remaining just to me now to write the answer. Okay, and that is from negative 3 up to 0. Now you can see 0 was not part of the set A, so it can't be part of the intersection. Oh, sorry, that is negative 3 I meant. And then 0 is not part of the set B complement, so it also can't be part of the intersection. Now the tricky part is this. This is 3 marks. If you just miss any bracket here, you will lose marks. Others can even remove all your marks. Okay, imagine you just came and put this. Everything else is correct. That is wrong. Okay, supposed to be. Mhm. So if you can see, 3 negative 3 is not part of this set here. So as long as it's not part of that one set, it means it can be part of the intersection. You can see an open circle there. That's a meaning. Open circle means it's not being included. Are we okay? Okay. So that is for that first one. Now let's go to the second one. Don't worry if you get confused. Just continue listening. There are a lot of questions here for you to understand. So I want now to work out A minus B minus C complement. Now you need to know that a minus means intersection complement. So if I've got A minus B, this is the same as A intersection B complement. This is what you need to understand, okay? So the first thing is we need to simplify this set. Yes, please, we can go on. So understand on this one. I'll take time. Make sure you understand on this one. And so it's easier when you guys ask when we are still on the question other than after I've removed the question, because it's hard for me to start again over. Okay. Okay, let's look at this one. A minus B minus C complement. Now we want to simplify first before we can answer the question. I've already said that minus means the thing that has got a minus is going to have a complement. So this means that this is A. I'll first get this minus here. Okay. I'll change into intersection. This will mean that the entire of this term which is on this side is going to carry a complement, because the whole of this term is representing one thing, just like this B. So you give it a complement when you change the minus into an intersection. So now you have got two complements. And we talked about this. What does two complements mean? What will happen to the two complements? Yes, they'll cancel each other. So this is just A intersection B minus C. And this also means A intersection B minus C means B intersection C complement. Okay. So I've simplified. I can now answer my question. The first thing first that I'm going to do is I'm going to work with the complement. Now, write always first the universal set from -10 to +10. These two guys are not being included. Now, the one with a complement is a C, okay? So I'll go to my set C. C is from 5 to 1. Let's say 5 is somewhere here. Sorry, -5, that's -5. So when you're writing again a set, you can't start with a big number and then you write a small number. That's wrong. Okay, you can't write a range like that. You always start with a small number and then a big number. Okay, so it's moving from -5 up to +1. Now, because I want C complement, look at this. Is the 5 part of the set C? -5, is it part of the set C? So is it going to be part of the complement or not? It will not be. So I'll put an open circle here. How about 1? Is it part of the set C? Is it going to be part of the complement? Yes, so I'm going to shade that one and then simply join this side and also join this side. So what I've written here is C complement. And I'll now get the set B. The set B is from 0 all the way up to 7. And we are including both 0 and 7. Now remember, we want to get where these two sets are intersecting. So they are intersecting from here up to here. Okay, yes. And you can see the set B has got a 1. The set C complement also has got a 1. So I can now write this one on another number line just for cleanliness sake, 1 up to 7. So 1 is in the set B, is also in the set C complement. So it will be part of the intersection. And then B is part of the set, 7 is part of the set B and part of the set C complement. Is it going to be part of the intersection or not? It will be part of the intersection. It is part of the set B, it is also part of the set C complement. And you want where B is intersecting with C complement, so it's going to be part. Okay, so that is B intersection C complement. The next thing that happens is we now go to our set A. So we have already found this second part. Now let's get the set A. The set A is from -3 to 2. -3 is here, 2 is going to be somewhere there. You can see we are not including -3, but we are including 2 in the set A. And we want where these two sets are intersecting. So they're intersecting here. So meaning that the final answer for A minus B minus C complement is going to be 1, comma 2. 1 is part of both sets, so we're going to put this. 2 is part of both sets, also we're going to put this. So this is going to be the answer. Okay? Are we okay here? Where? Look at this. 1, C complement we have shaded there, meaning that 1 is part. And for this set B, you can see that the set B starting from 0 up to 7. It means that 1 is part of that set. If you are taking the intersection of these two sets, it means that 1 is part of the C complement, it's also part of B, so it will be part of the intersection. Intersection means where things are meeting. So if something is in both sets, it means it will be part of the intersection. Is that okay? Is there another question here? Okay, let's look at the next one. The sets A, B, and C all intersect, and U is a universal set. Shade the set described by the set which has been given there. Okay, so want to shade. Yes, there's a hand. Please, you can go on. I can see a hand. Okay, we want to shade this set. You can't shade before simplifying. So distribute the complement that is outside. So this is going to be B union A complement. What happens to the sign inside? It becomes union. Okay, and then we are going to have C because we're going to have two complements. Okay, so like that. Now, the question clearly states that A, B, and C all intersect. So A, B, C, they are all intersecting. Now we want to shade this set. The first thing is what? A complement union C. A complement union C. A complement union C means shade everything that is outside A and also shade the entire of the set C. Okay, that's the meaning of A complement union C. So A complement first, let's shade A complement everything outside the set A. So this is A complement. Now union C. Union means also shade C. So I'll get also the entire set C. I'll shade it. So this is A complement union C. And then union B. So also shade the entire set B. So also get the entire set B and shade it. So this is the answer for this one. Okay. That's the answer for this set. Is that a question? Okay, let's go to this one. Given that A and B are sets, express, what do you want to express? A intersection A complement intersection B complement complement in the simplest form. First thing first, we're going to get this complement outside and distribute to the inside. Okay. So I have asked that any hands which are up, you can ask, no one is responding. So please, if you have got a question, just be able to open your mic and speak. Be free. Okay. Okay, you are going to get on this one. There's another on this one here. So want to simplify as far as possible into the simplest form. Okay, we'll still use this same one here. So there are a lot of different ones. You see how different they are going to be coming. Okay. So let's first distribute this complement to the inside. How is that going to become? So we're going to have A complement. Now take this entire term here as one thing. Okay, because they're in brackets when you're distributing a complement that is outside. So the sign here will change from intersection to union. And then what is now here A complement intersection B, there's a complement. It is going to have another complement. And you know that when you have got two complements, they cancel out. Okay, like that. Now the next thing that I can do here, now the thing is, even if I use the distributive law, okay, for that sake, let me use it, but then it will not change and it will barely take you. The distributive law is you get this A complement union, so it becomes A complement union, distribute to the A complement inside the brackets, and then get the intersection on the middle, and then the same A complement union, distribute to what is inside the B. Now we had mentioned that A union A is A, so meaning A complement union A complement is A complement, and then there's a intersection here, and then we have got A complement union B. Now, in case you can't see when you reach at this point, remember I said when you're simplifying to the simplest form, you shouldn't have the same letter twice. So the best you can do is try to use a Venn diagram. Okay, this is the set A, this is the set B. Start by the side which is complicated. A complement union B means shade everything outside the set A and also shade the entire set B. So also shade this set B. So that is A complement union B. Now you want where this set is intersecting. To intersect means to meet with what is outside A. So the answer is just A complement. Hope you can see that. Look at the set that I've shaded. I've almost shaded everything except that part of A. That's more part of A. Now we want where this set I've shaded is meeting with what is outside A. So it will just be that part outside A. Hope you can see that. I just hope you can see that. Is there a question here? So if you leave it here, you'll not gain 4 marks. The answer is supposed to be a complement. Okay, let's go now to B. In the Venn diagram shown below, shade B minus A minus C. Now we have just said that minus means intersection complement. So let me start with what is inside here. A minus C means A intersection C complement. Okay. Now take this one, the whole of this thing as one thing, and change this minus into an intersection. So meaning that it will become B intersection A intersection C complement. So the whole of this term here will carry a complement because we change the minus into an intersection complement. Now I'll distribute this complement here to the inside. So it becomes B intersection A intersection C. Or let me distribute. So we're going to have A with a complement. When we distribute a complement, the intersection changes into union. The C also gains a complement, but it already has a complement, so it will become just C. Are we okay here? Okay. Now we want to shade this part. So we'll start with this part first. A complement union C means shade everything that is outside A and also shade the set C. Everything outside the set A. Everything outside the set A is this. Okay. Everything outside the set A is everything. Union C meaning also shade the set C. Shade the entire set C. Now you can see that A is being has been engulfed. So meaning we still shade it also. Now what we have shaded here, everything that we have shaded, we want to shade where it meets or where it intersects with the set B. Only where it intersects with the set B. Where is it intersecting with the set B? Let's shade the set B. So the set B is this one. So we want where the red lines are intersecting with the, the blue lines. So it's just set B. That's the answer. So just shading the entire set B. That is going to be the answer. Okay. So this is it. Okay. Let's work out C. Mhm. Oh, that would be far going back to that one. Okay, there is another question down, so we'll do it. So let me ask again. If you miss it at any point, be quick to ask on that one because it will be. There are a lot of questions in this papers we need to answer so that we just get an understanding. So be very free to ask when we are on that question, okay? So let's work out C. We have got a lot of questions like A, so don't worry. Let A be from negative infinity to 3, B from negative 3 to 3, C from negative 1 to 6, and R be the inverse set. Now, R is the set of all real numbers. Want to find the set A intersection B minus C complement. Now, first thing first, you need to be able to simplify this set. This means A intersection B, B minus C means B intersection C complement. Then there's another complement outside. So I'll distribute the complement which is outside. That becomes A intersection B complement union C. Now, as I've always been mentioning, first look at your universal set. Now, here the universal set is a set of real numbers, meaning it's not a restricted universal set like others. This one is not restricted. So I'll just go to the one with a complement, B complement. So where is B? B is from negative 3 to 3. Are we including negative 3 in B? Are we going to include negative 3 in B complement? No, so I'm going to put an open circle. Are we including 3 in B? So are we going to include it in B complement? Okay, we are going to include it in B complement because it's not part of B. Now write an arrow going in this direction. Here you can see I'm using an arrow because the inverse set does not have a limit. You only end if the inverse set has a limit. Okay, so this is going to be B complement. If you don't show the arrow, that's wrong. And then now I'm going to write the set C. The set C, you can see it's from -1 up to 6. -1 will be somewhere here, 6 is going to be somewhere here. And we are not including -1, but we are actually not also including 6. So we want to find the union of these two sets. Now, if you remember last time we said union just means combine. So if I combine these two sets, I'll get everything. Like I'll get all the way up to here, but here we're going to pause and then we'll continue from here. Okay, we are combining. So it will be from -3, but -3, remember, is not being included, going in this direction. And then from -1, remember -1 is not being included, going in this direction. That is combining. So this is going to be B complement union C. It's different from intersection. Intersection would be looking for what is common. Union is combine the sets. Are we okay here? Are we okay? Okay, so this is not even the final answer. But if you wanted to write this is like if you wanted to write it as a set, is from -infinity. Now infinity, you always use open interval brackets to -3 union from -1 to +infinity. If you wanted to write that down. Now we're also going to get the set A, but the set A you can see starting from -infinity to up to 3, from -infinity up to 3. So 3 somewhere here. So it's like this. We are starting from -infinity up to 3. Now some of you might ask, we are starting, but why is it that I'm writing an arrow going in this direction? Okay, that's the meaning. Even if you can see the arrow is pointing in this direction, that doesn't mean that that's where we are going. That is where we're starting from. You always start from smaller numbers. Okay, there is a hand. Please, you can go on. There's a hand I saw. Please, you can go. You can ask. Or I don't know if it's a question or something. Okay. Seems there's no speech there. So now we want to find out where these two sets are intersecting. Now remember, intersecting is meeting. So first they are meeting from here all the way. You can see both are pointing arrows to the left. And then they're also meeting from here up to here. That's intersection. Okay. So to write it as a set now, the intersection of these two sets is from -infinity. We are ending at -3. Is -3 going to be included in the intersection? It will not. Why? Yeah, because it's not shaded here. Okay. Infinity, I've said you always use open. You should never use close for infinity. And then we put union because we are continuing like from -1 up to 3. Are we going to put open or close on -1? How about at 3? At 3 we'll close because 3 is in both sets. It's here, it is also here. I hope this is okay. If it is not, don't feel shy to ask. Okay, let's work out D. Yes. Uh, it's not necessary. You only name things that you are dealing with. Okay, ara is a set of all real numbers. In other words, it just meant that the entire, all the real numbers, that's the universal set. So you can't even name the set. If you wanted to show that one on a number line, you just put arrows like this that to represent all the real numbers. Okay, want to now simplify as far as possible. Q union P complement minus P minus Q complement with another complement outside. These things are very easy. Okay, these things are very easy. Just tell your soul to know that these things are very easy. The first thing I can do, I want first to deal away with the minus here, the big minus, because I cannot distribute this complement as long as that minus is 8. It might confuse me at one point or the other. So this will become Q union P complement. I'll change this into intersection. If I change it into intersection, it means that the complement will come here. So you see that we now have two complements. And what will happen to those two complements? They will cancel out, yes. Okay. So I'll remove them. If you're not clear how that is happening, please ask before we go too far. It will be hard for me to come back at this point to explain on that one. Now I can distribute this complement which is outside. So I'm now going to have Q union P complement. Okay, what's not clear? Which one? So when we change a minus B means A intersection B complement. So we are changing that minus to intersection. So what happened is that the second thing that has been named here, we had to put a complement. That is how it came about. Okay. Yes, Mishak. Oh, oh, thank you. So this is Q, this is P minus Q. Okay, so what we are doing now is we are distributing this complement here to what is inside, all right? So that is what we are doing. So remember there is a complement here. So if I distribute another complement, there will be two complements and they will cancel out. According to De Morgan's law, the sign here is going to change. It becomes union. Then if I distribute this other complement, it will come there. And then we can go on. This is Q union P and then union. Now what is inside again, I'll change. It becomes P. Where there is minus, I put intersection to be Q complement. Remember there's another complement outside. And this is going to be Q union P union. If I distribute the complement outside, it will become P complement. The sign changes inside, it becomes union. Then it becomes Q. Because I've got Q here, I also have a Q here. I want to start with Q, so I'll use the commutative law. So this is Q union P union. So I can actually swap this. I can start with Q and then union P complement. Here there is Q union Here there is also Q union. So I can write that Q union. And then I'll write the P which remains here. I'll get now this sign on the mid which is union. And then I'll get the P complement which remains there. So this will give us Q union. Last time we had mentioned this. What is P union P complement? Universal set, alright? And then if a set, if you get a union of a set with the universal set, what will be the answer? Say universal set. Okay. So if you get a set and you take a union with the universal set, the answer will be a universal set. If it was intersection, the answer would be that same set. So that is it for this question. Okay. Let's look at this. The sets A, B, and C all intersect, and U is a universal set. Shade the region described by the set. And this was it was a nice question. A union B intersection C minus A intersection B. So the first thing that you want to do is do away the minus. So this is going to become C intersection, and then you're going to have A intersection B with a complement there. Okay, that is what you're going to have. Now you can shade. Being told that all the sets intersect. If this is A, this is B, this is C. I'll start with this one. A intersection B was supposed to be this region here. But we want A intersection B complement, meaning that shade everything else, but not that region which I've put in blue. Okay, that's the meaning of A intersection B complement. But we want to shade everything, meaning we want to shade everything, 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 everything. But then we want where it that region meets with C. That's the meaning of intersection. Even if you want to shade what is outside A intersection B, but it should be in C. You're not shading just everything. You are shading what is outside A intersection B, but it should be in C. Okay, so meaning the region is going to be this. This. This region I've shaded is outside A intersection B, but it is in C. Hope you get that. Is that clear? This region I've shaded is outside A intersection B, but is in C. Is that okay? Okay, and we want now where this set is going to intersect with A union B. A union B means get A, get B, you put them together. The union of A and B is this set. This set I'm shading. The one I've shaded in green. That's A union B. So I want where the blue things are intersecting with the green things. Hope you can see where the answer is going to be. So these guys are only intersecting here. I don't know if this is clear enough. They're only intersecting here and also here. Let me draw them. So they're only intersecting here and also here. That's the only region where A union B is intersecting with the other set. I hope it is okay. So you see, there's nothing complex about sets. The thing is just follow rules. You end up getting them all. Nothing complex at all. Okay. Yes, please. Nimfuta n'okufuuta so nshiremona. Is twalamu na pa question imbi. Okay, so let's give this one x union y. Yes, that was the answer. You only shade those two places I shaded. Okay, we want to simplify as far as possible this set. First thing first, distribute the complement to the inside. So it will become x union y with a complement. The sign here changes into union. And then we're going to have x union y complement. It also gains a complement. And then I'll distribute the complements to the inside. So it becomes x complement. What happens to the sign? What happens to the union? Intersection. Very good. And then this will still be there, and then this will be x complement. This also changes into intersection. But what will happen? What are we going to have? Y complement. Just y. Excellent. Okay, just y. Now you can see x intersect, x complement intersect, and x complement intersect is common, so I'll factorize that x complement intersect. In the first bracket, what will remain is y complement. We'll get a sign on the middle here, which is union. The second bracket, what we'll get is a y. So it becomes x complement intersect. What is y complement union y? Universal set. And where does the universal set intersect one with another set? So what will be x complement? Yes, the same set. Good. So this will be the answer. Now mwanakyali yangu kefi. Mm. Okay. So should I answer the question C, or you can answer it now? Okay, so let's go. We want to find, we have been given set A, the set B, and this one was, I think it was the trickiest of all the questions which I gave you. Okay. That is because here we have got, look at the set A. The set A is not an interval set. It is elements. You can see these are curly brackets. So these are elements 0 and 5. It's not a range. So when we want to find the intersection B, we need to first write this on a number line. The set A is 0 and 5. Now the way we write this is just like this. You don't write a line anywhere. This is A, this is A. These are elements, it's not a range. Okay? And then the set B is from -1 up to 2. It's actually from -2 up to 2. We're including both sets or both elements. So where A and B are intersecting, where they are meeting, you can see it's only at 0. And you write this as an element. It's only 0 which is common between the set A and the set B. If you can't write one element as a range. No. You write it as an element. That's why you use curly brackets. Any other brackets you use for this one is wrong. Is this okay? So if you look at this, the set A only has got 0 and 5, but the set B is from -2 to 2. 5 which is in A is not in the set B, but 0 which is in A is part of the set B. So meaning it's going to be part of the intersection. So to write it on a number line as a final answer, it will just be like this. So this is A intersection B, just 0. It's the only element which is found in the set A and also in the set B. Let's answer B minus C minus A. Now B minus A means B intersect A complement. Sis, I want you to get this well. So the set A has got 0 and the set A has got also 5. Is A going to be part of the complement? I mean, is 0 going to be part of A complement or not? Is 0 part of the set A? Is it going to be part of the A complement? Okay, it won't. How about 5? Is it part of the set A? Yes. Is it going to be part of A complement? No, it won't. But remember, these are not the only elements which will be outside A. Actually, everything else, okay, will be outside A. These two guys, okay, like that. So what I've shaded here is what? A complement. It's only 0 and 5 which are not in A complement because they were in A. All the other elements are going to be outside A, apart from 0 and 5. That's why I've put open circles at 0 and 5, because those guys are in A. The rest of the elements you can think of, they are going to be outside A. That's why I've put those brackets. I mean those arrows you can see everywhere. Yes, please. Definitely. Very good. Okay, so now let's write the set B. The set B is from negative 2 up to 2. We are including negative 2. We are also including 2. Now we want where these two sets are meeting, where they're intersecting. So the intersection of these two sets are going to be these regions. You are going to have this region up to 0, and then from 0 up to 2. 0 itself will not be part of the intersection. Therefore, B minus A is going to be from negative 2 up to 0, and then from 0 up to 2. 2 will be included, negative 2 be included. 0 will not be included in the intersection because it's not part of the intersection. This is how we're supposed to write the answer. Is this fine? Okay, union just means that we are just combining because we have got two parts where they're intersecting. Okay, now for this question here, I want you to try it out. You might think it's complex. It's not complex. The only thing is you just simplifying it. Yes, please. For each question. Yes. Okay. So please try this one out. I'll be expecting the answer they try. The only thing is just simplify and then be able to answer. Okay. Let's look at this question here. Hope you can see. Hope you can see it. Use set notation to describe the shaded region in the Venn diagram. Anyone who can help, how can you describe the shaded region? I like this question. How can you describe the shaded region? Okay, before you answer this one, let me maybe give just to open people's minds. Imagine you are given this. They said describe. How would you describe this set using set notation? A complement. Good. So that's the same way. How can you describe this set here? I should have given you this one as a quiz. We would have seen A intersection B. Should I put in brackets or not? Okay, let me draw for you what you've given me. A intersection B complement means everything outside where these two sets are intersecting. That's A intersection B complement. This is what you've given me. Is it the same with what has been given? Uh-huh. Wow. Okay. I'll laugh properly after the class. Okay. I love that one. Uh, okay. The universal set is always intersecting everything. Okay. Yes, please try. A complement intersection B complement. This one is the same as A union B complement. And the meaning of this is that we should have shaded what is out. Okay, let me shade for you what you've given me. So this one you've given me is this one. That's the one you've given me. Ah, you didn't we used to shade these things in high school? So you've seen, huh? That there's nothing to be taken for granted here. Okay. Mhm. Hmm. All right. So let me show you. So I'll start with this part in A. If you look at that part in A, that part is B intersection. Okay, we have got B intersection A complement. What is in B but is outside A, but is not this part? What is B but is outside A is this part here. This part here is B intersection A complement. Okay, and then this other part this side is A intersection B complement. So we are just combining these two parts. That's the set here. As simple as that. Okay, so okay, so B intersection A complement is different from B union A complement. Let me show you the difference between these two. So for the first one, which is B intersection A complement, it means what is outside B but is in A. So it's only this region. It is outside B but it is in A. Now B union A complement means what is outside A also shade the set B. What is outside A also shade the entire set B. So this is this one. So because it is we are only interested in what is outside A, okay? Oh, I'm even shading like a wrong set here. A complement. So this one's supposed to be A intersection B complement. What is outside A? I mean, what is outside B but is in A? I change the values. Okay. So this question down here, we have already answered. We have already answered one. Let me just answer it for that sake, so that will not leave anything untended. I want you guys in your first test. You need to give me hundreds. The first test, first quizzes, those things are the things you can get 100%. Given that a is from negative infinity to negative 2, you gosh, this question was beautiful. I didn't see properly. Okay, we want to find b minus a. Now we know that b minus a is b intersection a complement. Okay. Now we've been given that a. Let's first show this on a number line. We've been told that a is from negative infinity to negative 2. Negative 2 is being included. Oh yes, thank you. And then 5 to infinity. So this is the set A which they've given from negative 2, from negative infinity to negative 2, and then from 5 to infinity. That's the set A. And then the set B is from negative 3 to 6. So negative 3 is going to be somewhere here. 6 is going to be somewhere here. We are including negative 3. We are not including 6. This is B. Yes, please. Mhm. So you never shade the arrow, okay? So the arrow is never shaded. You only shade at these ends. So this is the set A. But look at the question that you've been given. What you've been asked is to find B intersection A complement. Now A is starting from negative infinity to negative 2, and then from 5 to infinity. Meaning that the only thing that is outside A is between these 2 points. These 2 points. This is going to be A complement. This 5 will be shaded because 5 is not in A, but negative 2 will be open. Because the rest of the elements are in A. So this is the only region that is outside A. So this is the region that you want to intersect with the set B. And the set B, I've written it there. So you can see the intersection of these two sets is actually here. So meaning that the answer is going to be from negative 2 up to 5. 5 will be included, negative 2 will not be included. So this is it. Is this okay? Okay, I would have ended the class a long time ago, but I just want you to be familiar with a lot of questions. Let the universal set E be the set of letters in the English alphabet such that you've been given those. Want to find A intersection C intersection B complement intersection C. Now we'll start with A intersection C. Just look at what is common in A and B. Be telling me the elements which are found in A and in C. What elements can you see in A and in C? S and E and R. That's all. Okay. And then let's find B complement intersection C. Now the meaning of this is you want elements which are in C but they are not in B. That's B complement intersection C. They are in C but not in B. What elements are in C but not in B? R, E, and P and S. Okay, these are the ones, isn't it? Is there anything else? No. Now you want what is common between these two sets. That's the intersection. So find what is common between these two sets. Okay, just E and R. So that is going to be the answer. Oh, even S, eh? Okay, so that is it. Okay, there's a mic that is open in the background. Okay, let's answer this one. Simplify the following as much as possible where A and B are any sets. So let's start with the first one. The first one is A union B intersection A union B complement. Now you can see there's A union, factorized A union. Then you remain with B, get a sign on the middle, intersect the other side, you have got B complement. What is B intersection B complement? Empty set, good. And then A union empty set, it's A. Okay, so that is the answer. It's A. So let's consider now this one. We have got A complement union A intersection B with a complement and then another complement outside. What should be the first thing we are going to do? Okay, so it is going to become A, right? What happens to the sign? Change it to intersection, and then we're going to have A intersection B, isn't it? These two complement will still cancel, isn't it? Now, at this point, I know you might not be able to see, but between A and A intersection B, which one is a smaller set? In other words, which one is yes. So every time there's an intersection of two sets, you always get a smaller set. So the answer here is going to be A intersection B. In case you didn't see that, this is A, this is B. A intersection B is this one. You want where A intersection B is meeting the whole set A. It is just intersection B itself. Okay, so that will be the answer. Okay, so this one now, you are going to be able to try it out. Also, this one, you are going to be able to try it out. Also, this, you are going to be able to try it out. And that will be it. In the next class, we are going to begin SADS.